In this video, I'm going to walk through the workflow I use for mapping out Keyline-based agroforestry systems and generating accurate tree and plant counts for establishing and planting out Keyline agroforestry systems such as silvopastures and larger multi-species orchards. In this video, we are utilizing QGIS or QGIS software, a free and open source GIS mapping platform, and I will assume basic knowledge of the program. Links to download QGIS can be found in the descriptions below this video. In this example, I'm going to generate a silvopasture planting plan and get tree counts based on the following contextual parameters for a client property located in eastern Tennessee of the United States. This is the area of the silvopasture block under consideration. It's a hilltop location currently in pasture. The mid-slopes are ranging from 2 to 3% grade, so very shallow, with a solar aspect that basically is about 360 degrees. It's got just about every bit of solar aspect you could want. The silvopasture block is to be bounded by a low standard farm access road. That is the tan line that you see running around that block area here. And then just adjacent to and downhill of that is this blue line, which is a swale. And these two elements together, the road and the swale, serve as part of the mainframe water harvesting system that is going to be capturing water from this roughly 7.5, 8 acre area up here and moving it towards a saddle down here. Let's see if we can highlight that. This pond, there's an opportunity to put in a saddle pond down here. So we're gonna be limiting runoff to some of these lower regions, preventing some of the ongoing erosion head cuts that are happening here at these two little red X's. And we're gonna be storing water as high as we can in the landscape for additional uses. The road in this case will serve as our master line, this section of road right here. Let me see if I can highlight that. Let's go here. And so this road is going to be our master line. That's going to be the contour line that we base the entire planting pattern off of, and then we'll progress it steadily uphill through the entire block to maintain consistent width between different tree planting rows in case they want to bring in hay equipment, mowing equipment, and as we'll talk about a few other benefits of that as well for rotational and planned grazing. The trees to be planted will consist of a mix between early and late season livestock fodder tree species such as white mulberry, poplar, hybrid willow, black locust, some grafted thornless honey locusts, American persimmons, Japanese persimmons, to name a few of the starting candidates. Additional plantings of mash trees such as chestnuts and oaks will happen around the perimeter. The between row distance is going to be 50 feet. And we're going to have an in-row spacing of 40 feet between the trees. The goal here is to attain a roughly 35 to 40% shade cover throughout the silvopasture during any time of year. And this is going to help to improve manure distribution by the grazing animals that are going to be seeking shade between feeding times. And it's also going to allow for easy running of polywires for rotational grazing and flexibility in paddock orientation and size. And in many cases, the tree trunks themselves could be used as fence posts. What's nice about having a regular spacing and having a keyline setup like this is, assuming you have 4 trees, again 2 from each planting line, you've got roughly a rectangle with 50 by 40 dimensions. That's going to cover roughly 2,000 square feet, which is roughly 1/22 of an acre. Again, it's pretty darn close. This is going to help make the sizing of paddocks for daily animal rotations much quicker and easier, as the pasture is going to be basically full of easy visual references from marking areas. By simply walking down one row of trees a certain number and then walking across rows a certain number, you can get precisely sized grading paddocks based on the number of animals and the class of animals that you have on site. If we're assuming an average canopy radius of 15 feet, so that means a diameter of 30 feet at maturity across all tree types roughly, that means that each tree is going to cast about a 710 square foot shadow footprint that's going to move throughout the day. And that's going to equate to roughly that 35 to 40% shade that we're looking for every 2,000 square feet of grazing cell area. So this density of dappled shade is going to help also to keep the forage quality much higher for longer into the warm season by keeping lignin levels lower when you don't have the forage exposed to that really intense sun. And therefore, we're going to have the animals eating higher quality food that's going to help them gain weight faster. Basically, we're trying to create an all-you-can-eat ice cream bar for ruminants here, as well as we'll be adding the foods from the different fodder trees, the greatly increased variety and nutrition from both leaf, fruit, and mass crops. Okay, so let's get started here. Okay, our first step here is to trace out our master line, that main contour line that is going to set the planting pattern for the entire block. In this case, we're going to be following this road that is on the eastern and northeastern and kind of northern edge of the planting block. That's going to set our main pattern for all the successive rows. So let me delete the block area here, get that out of our way, and we're effectively just going to trace the road. So I'm going to go up here and create a new scratch layer, or you can do that by going to Layer, Create Layer, New Temporary Scratch Layer. I'm going to make that, I'm going to call this our planting reference line. Our geometry type is going to be line string, and then we're going to select the same projection that we have for the project CRS. We say OK. So we're in that layer. The layer's been made editable, not edible. And we're going to add a new line feature right here. I'm going to start up here in the high corner and just start working my way around, making the master planting line. And what I can do to speed this up if I want is to enable tracing, and got snapping on. Again, this could be working off of an imported line. Maybe you walk the landscape with a GPS and you've already flagged out exactly where that contour is. You can import that into the design software and use that as your master line as well. So we'll take it to right about here, and that should be good enough for what we need to do. So I'll save that. Okay, and adjust that color there. Let's adjust it up to white and make it a bit thicker just so it's easy for us to see. So that's going to be our reference line. In fact, let's change it to red so we're not confusing the other contour lines. I might just turn those off for now too. That'll make this a little bit simpler to see. Okay, so contours are off. So there we have that big red line. That's our reference line for setting up this planting block. So the next thing we need to do is create the appropriate distance of offset line that'll be our first actual planted line, because we don't want the trees planted in the middle of the road, nor do we want them overhanging the road too much. In fact, we're trying to take our average canopy radius and basically have that come right up to the edge of the drivable area, so we don't have to deal with a lot of overhead pruning, because a lot of these trees are going to be kept pretty low because the idea is that the livestock are going to be able to graze from them. They might even be coppiced or pollarded, you know, again, just at shoulder height, or coppiced might be cut off at ground height. So we're going to create an offset line that will be the actual first planting line used in the block, but we're going to inset that off the road so that the average tree radius is going to come right up to the edge of the road and not extend over it. So how do we do that, right? What we're going to do is go down here to our processing toolbox, or again, you can access that by going to the processing in the menu and go into toolbox right here. But down here, I'm just going to type in offset, and we're going to look at creating offset lines. In this case, we're just creating a single offset line, so we can do this one. For the other steps where we're creating multiple offset lines that are all effectively one is being made after the other, we're going to use this array of offset parallel lines. But if you're just trying to do one line, you can go to offset lines. We'll double click that. We have our reference layer selected, the planting reference line. Our distance off of that, in this case, is going to be half the width of the road, which is going to be 6 feet. The road's 12 feet wide, plus the radius of the tree. So that's 15 feet. So 6 plus 15 is 21. So I'm going to say 21 feet. We're going to offset it. The rest of this we can pretty much leave exactly as it is. Don't need to worry about doing anything. We'll click run, close that, and then here we are in offset. Let's see if we can make this more visible. We offset it the wrong direction. It's good learning. So again, we'll just delete that layer. We'll run this one more time. But so in that case, I left that number as positive. Positive will send the offset to the right. If you set the distance as negative, it'll go to the left. So we should have done negative 21 feet. Leave everything else the same. Run, close that. Let's make this visible. Turn that to white, make it a little bit thicker. And there you have it. We've got an offset line about 21 feet inset from the center of the road. And that'll be the first actual planted line of this silvopasture block. Now for step 2, we're going to generate all the successive planting lines that are going to fill up this paddock. So we have our offset line, basically our first planted line already created. That's going to become the reference for what we're about to do next. We'll again go to the processing toolbox up here in the menu, or I already have that loaded in my side panel. We've typed in offset, right? You can also type in parallel, and that'll bring up array of offset parallel lines. That's what we're going to click. So double click that to bring up the box. And same thing here, we're going to make sure we have the appropriate input layer selected. So we have offset, right? That's the name of our first line that we just created. We're going to create, now we get to select how many different lines are we going to create, right? So we'll go with 10, see if that's enough. That should be plenty to fill this paddock up at our selected spacing. One interesting feature here is this, it's grayed out currently, but selected features only. That's if you're using a layer that has multiple line elements, you may want to just select one specific element. So usually if I make that editable and we go back to this, right? You would have, and there were multiple lines in that layer, you'd have the option to just say selected features only. And then what you'd want to do is basically use the selection tool here, go into the layer, select that specific line, then go back, and you'll see the option to select features only. That means it's only going to generate lines off of this one line you have selected instead of all the lines across your map, which could make a real mess of things. So again, just to keep it cleaner for you, we'll pretend like we've got multiple lines in that layer. We're going to make 10 offset lines, and now we're going to start to set up our between row spacing of 50 feet. So we're going to say our offset distance is 50 feet. Okay. I might just boost that up to 16 in case we get a tight corner. 50 feet. We'll call it offset lines and run. Okay, so again, this is helpful, right? You can see here on the map, they generated out to the right into the forest. So what I got to do is say minus 50 feet. So let's go change parameters. We'll try it one more time. Minus 50, 10 times, run it. Bam, there we go. Okay. So we'll delete that first one, remove that layer, say okay. All right, so now we're just left with the new offsets. Let's make this visible. Okay, we'll leave that in the bright purple. It's fairly easy to see. Okay, so we have our offset lines. Obviously they extend beyond the size of the paddock, right? They're way out here into this other block of woods. So we wanna trim those back. We also want to shape them. So let's shape the lines first, because when we're making these agroforestry systems, what we're looking for are these nice smooth curves here, because we would like to retain the ability to potentially bring in hay equipment, use a mower, or thinking of using some sort of mechanization in the landscape. And as you can see, as we progress down this way, these corners get sharper and sharper. And that leads to major inefficiencies if you're trying to bring in equipment to maintain the landscape. So to keep that option available to us, we need to smooth these lines out. So to smooth these lines, there's a couple options available. Again, we'll go down here to the processing toolbox. I'm going to type in smooth. There's a vector geometry tool called smooth, and there's also a Sega vector lines line smoothing tool down here. We're just going to go with the vector geometry tool for now. Click that up to bring up the dialog box. We'll run it for a few iterations here. Let's try 5, see how that looks. Run that. Okay, that looks pretty good. It misses a couple of the corners, but we can touch that up manually. So we've got smooth here now. Let's click off that so we can see it. And let's change the color. Let's change that to white so it's more visible. And we'll increase the thickness a little bit. Okay, so we might want to go in here to a corner like this one and say, hey, I don't know why that stayed sharp, but we're going to just change that. So I'm going to make the layer editable. Go to my point selection tool here. You can see for some reason there's a hyper density of points that were added in this location. So I'm going to start back here and just delete a bunch of these. So I'm just hitting delete after selecting one successively, and pretty soon here, there we go. We'll start to see that rounding out. Just deleting some of those points. So that's going to help us right there get a little bit better geometry. And same thing, I'm just deleting more of these excessive points which showed up for some reason, and we can always add one or two more right here in the middle just to smooth that out. But I think that'll be Pretty good for that one. Zoom back out, that looks much better. Let's do the same thing for this one up here as well. And again, we'll zoom in on this, say, okay, yeah, let's start deleting points from, say, back here. And just delete those across, round that edge out, add in one. That's good. Okay. Good enough for what we need to do. So now we've got all those different points smoothed out. Center up here. And now we're ready to clip these lines so that these lines that are out here in the forestry block that are outside of our planned planting area, we don't want those, and we want to clip them with that 21-foot buffer in from the road. So we're going to set up our clipping polygon next and talk about how to do that, how to get that perfect buffer, in this case 21 feet, that we need in order to make sure our planting lines are exactly as long as they should be. We're going to first create a reference line for this south and west facing road down here on the bottom so that we can again create our 21-foot offset from the center of the road, make sure we have enough buffer. We could also just create a polygon tracing the entirety of the road all the way around, but that might clip out our first planting line, which we don't want to do. So I'm just going to make a second line, we'll create an offset, and then we're going to basically trace a polygon on top of that just to make sure that we're not losing that first line. So we'll go up here, and again, we'll create another scratch layer. We'll call this the southwest reference line. Geometry is going to be line. Put it to our project CRS. Once we're in that layer, we've got, again, snapping turned on and tracing turned on. So we're going to go here and going to select that first dot on this line and then cruise all the way down. Good, check it's still following. That's great. Gotta love the tracing tool when it works right. Okay, so there's a good reference line for us. We'll save that. Make sure you guys can see that here. Make that a little darker. Okay, so there's that reference line running down the middle of that road. Now what we're gonna do is generate an offset. So we'll call it the southwest reference offset. We're gonna go down here to our processing toolbox, type in offset, create your offset line. And again, our distance this time, since we're moving to the right, is going to stay positive. So we're going to type in 21 feet for that, because that's how far we want to offset the clipping polygon. And 16 there. Go ahead and run. Okay, we got our offset line. You can see that now, right here. Make that a little bit bigger. It's easier to see. Okay, from that, we're now going to trace our clip polygon. So again, I'll go here, create yet another scratch layer, call it clip polygon, turn that into a polygon, set our map projection okay. We're in the clip polygon, and now we're gonna start to basically trace that polygon on top of these lines. So we got this one right here, we're gonna link them up, link that one to here, and then we're gonna follow this line all the way down. Perfect, it's tracing, that's good, that's what we want. And again, we'll follow this red line all the way around. Got a little bit there, a little bit off there, kind of lost the trace, but that's good enough. So there's our clip polygon. Let's make that a little bit see-through so you can see what we're working with. So we're gonna use that to now clip our smoothed key lines, okay? So we'll go up to Vector, Geoprocessing Tools, Clip. We're going to select our input layer of smooth, which contains our different key lines, which is right here. And then we've got our clip polygon selected to go over it. We'll go ahead and run that. Close that. So now we'll delete our clipping polygon. We'll delete all of our reference lines and our offset line. And let's delete smooth. And now we should see just these remaining clipped contour layers, or clipped key lines. Let me go ahead and rename that. Clipped key lines. Make that a little bit more visible. Okay, so there we go. We've got all of the different lines. We can even get rid of our original offset line there. And voila, we have our different key lines. So from this, we can get precise lengths of each key line, and more importantly, we can now get very accurate tree count projections. Like if you're doing a project and you're planning this out, this is where the real power comes in. Okay, so to get the tree counts on each line, we're going to go down here to our processing toolbox and we're going to type in points along geometry. Geometry, see if I can spell. Okay, right here under vector geometry, we see points along geometry. We'll click that to bring up the dialog box. So again, we've got our input layer selected, clipped key lines. So that's the entire total potential plantable length that we have in this paddock. And now what we're going to do is basically create our in-row spacing, which we decided was going to be 40 feet in this case. We're going to leave start and end offset at 0 because basically that means that we're going to be okay with starting with the tree right at the end of each line. If you wanted to say, okay, at the end of each line, I want the first tree to be 20 feet down that line, that's where you'd say, okay, I want my start offset to be 20 feet, something like that. And this is really helpful if you're creating interstitial plantings within an overstory planting. You can create another layer with an offset and bam, you've got something right in the middle of your overstory planting. So maybe some smaller stuff like berry bushes underneath, fruit trees or something like that. So we'll go ahead and run that, see how this looks. There's our points. That's great. Let's make those a little bit more visible. In fact, we can go, let's do map units here, and we're going to set them with a size of 30. Yeah, there we go. So 30, so that's going to be our total tree diameter or 15-foot tree radius. So roughly at maturity, if they were all magically 30-foot diameter trees, this is what the paddock would be looking like in terms of plant counts. And then we've got our interpolated points layer up here. If we want to figure out what's the total count per line, you can of course figure that out too. But in this case, you've got 180 different features. So this paddock is going to take 180 trees, might be one or two more over here at these edges, because I might get in there real tight and measure that just to make sure that that's as close as we want. We could probably fit another tree there and it wouldn't overhang the road. Maybe one more right there too. So again, that's the bulk of the work in terms of estimating, but you can see like the tree canopies stop either right up to the edge of the road or a little bit off of it based on the lay of the land. And there we have a Keyline agroforestry system laid out, right, following that master line that followed contour. And then really quickly, you've got a way to estimate the total number of trees you need, the amount of irrigation line you got to run, the amount of electric fence or fencing that's got to surround it. All of that can be cooked up really quick. So I hope this tutorial has been helpful for you guys, and please leave any comments in the notes below. As always, I'm learning and improving my skills, and if you have tips and better ways to do this, please share them. That's how we all get better. All right, thanks for watching, and go out there and design some forests.